Hello, it's Claudio, and in this video we will dig deep into Python decorators. Decorators are used in Python to add functionality to your code without changing the existing code. In this example, we will look at how to use Python decorators to increase the security of your code. First of all, I will define a list called numbers and a function called updateList that updates the element of my list by appending an additional element. Let's confirm that the function works as expected. Now, what if I have a system this function is part of, and I want to make sure that only logged in users can change this list? As you can see, I have defined a dictionary called user that contains a name and a logged in attribute. We will use the logged in attribute, that is a boolean, to verify if a user is logged in or not. And then I start writing the verify user function that will be used for our decorator. The verify user function takes as argument another function. Also, inside the verify user function, we define another function called wrapper. The wrapper function also takes the arguments we pass to the updateList function, and then inside the wrapper function we verify if the user is logged in or not. If the user is not logged in, we print an error message and we return from the function. Otherwise, we return the original function. And finally, we return the wrapper function object. The first thing you will notice about defining a decorator is that we are defining a wrapper function nested inside the decorator function. To apply the decorator to our updateList function, we use the @ sign followed by the name of the decorator. And now let's find out if this decorator works. The logged in attribute for the user is false, and that's why we receive an error from our program. If we set logged in to true, our program allows the user to modify the list. So our decorator is doing what we expect. And now let's improve the code of our decorator to give a bit more details to our user. If the user is not logged in, we print an error message. If the user is logged in, we print an informational message. This is useful considering that often applications log hundreds of thousands of messages. And now let's see what happens if we add an additional argument to the function updateList. This third argument contains another number that we add to our list. The code works fine without decorator, but when we re-enable the decorator, we get an error. The error is caused by the fact that the wrapper function only takes 2 arguments, so we need to include the third argument in the definition of the wrapper function and also in the return statement inside the wrapper function. As you can see, the decorated function works as expected. Despite the fact that our code works, this is not an ideal way to handle our code. Imagine if we had to add multiple arguments to the update list function, and then we had to update also the other 2 lines of our code for the definition of the wrapper function and for the return statement inside the wrapper function. So what other option we have in Python? Instead of passing the name of each argument in the definition of the wrapper function, we can simply pass 2 arguments that are used in Python to pass an arbitrary number of positional arguments or keyword arguments. I'm talking about args and kwargs. We will use those in 2 places, in the definition of the wrapper function and also when we return the function we are decorating inside the wrapper function. As you can see, the program is now working well. To show you how args and kwargs work, I will print the positional arguments that are inside args and the keyword arguments that are inside kwargs inside the wrapper function. When we run the code the first time, we only see positional arguments because we are not passing any keyword arguments. So let's update the call to our update list function to pass keyword arguments instead. So this time there are no positional arguments and we can see the keyword arguments passed to the function. And now one last thing for this video. I want to show you how it's possible to also pass an argument to a decorator. Why would you do that? Let's say, for example, our application has multiple modules, and we want to know which one of the application modules is logging a specific message. We can do that by passing an application module value to the decorator, and then use that value when we print an error message or an informational message. In this way, when we will look at our application log, we will know exactly which module of our application is logging a specific message. To pass an argument to our decorator, we need to add an extra level of nesting to the definition of our decorator. We basically create another layer of function that returns our decorator. Don't forget the additional return statement at the end of the function. And then we can specify the value of application module in the print statements that print the error message and the informational message. Our messages become a lot clearer to read and easier to troubleshoot. I know the syntax of decorators can be quite tricky, especially if you are getting started with them. I suggest to go through this example from the beginning and try writing this code by yourself. This will help you in the future if you want to use a decorator in your code, or if you're trying to understand the code written by someone else where a decorator has been used. Subscribe to CodeFather for more Python tutorials like this one. Let me know in the comments if you are finding this tutorial useful, and if you have any questions, also let me know in the comments. I'm really committed to help you in your journey as developer. Also, feel free to share this video with other people you know if you feel that they could get value from it. Happy coding and see you in the next video.